Hello, this is Team Restoration. Thank you for watching this video. Our aim for this robot challenge was to create something that could help using audio, a very versatile method, to determine ALS progression and pain detection in especially ALS patients. They often have trouble trying to do things on their own because of the mobility issue, and doing so, we can help alert others, making sure that we have more downtime for the caretakers, and we can also provide more assistance to the ALS patients themselves, making them feel more independent in their own homes. So currently there are many understaffed conditions that make it very difficult to be able to watch over many patients at once. This means that there's a lot of dedicated care to one specific patient that cannot be divided among others and has to be constant. With this, we hope to reduce that constant surveillance, making it so that we can improve the staffing condition, or mitigate it at least, of this problem, to make sure that we can all support these people much better. They are one of the populations that requires the most technology, but we haven't been able to support them. We are one of the only teams to have used audio with ALS to predict their progression rate, and so we're very excited to share our results. So, for ALS patients, we decided to make a home care robot where it resides somewhere inside the home. The ALS patient can be situated in any part of it, and because we're using audio, once it detects some sort of sound or wake-up call, for example, a specific term like come to the bedroom, it will respond, wake up, and travel to the ALS patient and can conduct some of its services. Our methodology includes taking the audio features from the dataset that we have used and from a pain dataset and an ALS patient voice dataset to convert it into different features. By extracting those features with specific softwares, we can train our machine learning models for many different purposes to help be able to establish a communication channel between the patient and the robot. And using the new features gathered from new data, it is able to predict and estimate either the pain level or the progression level of the patient. We analyzed over 50 features and we determined the top 2 to use. We tested 2 different models, a linear regression and random forest, and determined that random forest performed better with one feature. Doing so, we created a model which allowed us to implement it into our physical prototype.
So the other main contribution to this project is to design and implement a secure authentication module, because in real-world healthcare environments, it's important to ensure that only authorized users can access the system and interact with patient-related functions. To address this, we developed a 2-factor authentication mechanism that combines RFID-based identification and PIN-based verification. As a benefit of adding this module, we enhance system security, protect patients' privacy, and ensure safe and controlled access to the robot.
Our prototype consists of around $200 to $300 and is very cost effective, especially for in-home design. Our dual system design uses a Raspberry Pi as the analysis device and our Arduino as the mobility device. As Raspberry Pi hears a noise and detects a certain keyword, it turns on the system and tells the Arduino Uno to move to a specific location given what it heard. The Raspberry Pi continues with analysis and uses the models to determine different data, such as the pain level or the ALS progression prediction. Here is a demo of our robot in action. Bedroom. In this emulated environment, we have applied a fuzzing method to have a threshold of error of the keyword that the robot responds to. This allows tuning to the severity of the disease of the person and allows the robot to arrive at its destination and perform its task.
Okay, so here's a demonstration of our secure authentication system. So first, the user scans an RFID card using the MFR-C522 reader connected to the Arduino. The system reads the card's unique ID and checks whether the user is authorized. If the RFID verification is successful, the system prompts the user to enter a PIN through a keypad-style interface on the Raspberry Pi. Only when both the RFID and PIN are verified will access be granted, and the robot system can be activated.
Our system performance occurs over a period of 22 seconds, less than a minute, meaning it's very good for real-time response. Thank you for watching.